Nintendo Switch. Don't really know what's going on with this one, so we're going to switch it over to microscope and take a look at this port. I said it possibly could be the ports or something else, but I want to take a look at this port and see if there's anything going on here. There's a couple of little, oh, that's pretty loose. That should be a lot more solid than that, I think. Even the smash one's more solid than that, so yeah, I think we have a loose port. Yeah, it's lifting up from the pins, you can see. So I don't think we can really do any serious testing. See if I can get that in video for you. But yeah, the whole plastic centerpiece is lifting up from the pins. So I don't think it's viable as a port. So before we can do any actual serious testing, we're going to have to remove that port and go from there. So we will disassemble entirely, set up to remove the port, and then I'll come back. Okay, we're ready to remove this port. While I'm getting my equipment set up, let me throw up my temperatures. My expected temperatures for this job, as always, subject to change if the job requires it. I will note it in audio if I do change, but I don't expect to. So I do not expect to use the Pico pencil unless we end up having to do additional things besides the ports. The Pico pencil will sometimes get used to clear up, you know, excess solder or whatever when replacing one of the chips. So switch you back to microscope. Get you centered up and in focus. Alright, we will do what we always do. We will flood it with low melt, everything we can see anyway, and then we'll bring the sauce and we'll blow it off the board and go from there. Alright, another good pull. What you don't want to see on the port is little copper pads hanging on to those pins. And we do not, so that's good. Let's flip her around. Actually, I need to flip the whole board because the rest of this, or most of the rest of it, will be from the other side. So, give me one moment. Alright, we need to clear any bridges we have on these pins. And we do have a couple. Alright. Everything else looks good. Alright. Let's connect our meter for testing. Alright. Let's test and see if we have any additional issues. For this, we'll be going in continuity, so it's not that big a deal to have the meter connected. I'm listening for beeps, not readings. I'm not looking at readings, so in this particular case. So we'll start around the M92T36. We're going to begin with the Pi 3 USB capacitor, which goes to the M92T36 to the Pi 3 USB over to the other side of the board. The one we do not want shorted to ground is the one going straight, is the trace going straight to the chip. Okay, looks fine. And then we're going to follow the traces to the chip on all the rest of these capacitors. And we don't want any shorted. Okay, let's make sure we're getting good continuity or good connection. Okay, now we're coming to a capacitor that has two traces coming to the chip. On a capacitor, one side will always be ground, so as long as one side is ground, we're okay. Alright, and this guy here is typically CPU. If it's shorted, it's really not a good thing. Okay, let's move up the line here. We'll check around our MOSFETs, make sure everything is copacetic. Check this little filter. Good. Check our invincible fuse. Still being invincible. Now we're going to check around our test pads. This one should be ground. None of these should be shorted to ground in any way or have a pathway to ground. None of these should have a pathway to ground. Okay, let's check our big coil. Seems fine. We want continuity through that. And then we're going to do the same thing on the BQ24193. We'll check. Now it's going to have more capacitors with two traces going to the chip. Remember, one side will always be ground. I'm kind of checking the sides that I kind of remember not being ground. Alright, so one of these will be have a pathway to ground, one should not. Very good. Everything's looking good so far. Let's check our Pi 3 USB. Now that capacitor on M92 T36 usually is a good indicator on Pi 3 USB, but it's not 100%. I have had times where it does not read short, and then you can flip it over to the Pi, and then it is reading short. So, alright, so we want straight through continuity on these filters, but we don't want anything going side to side. You do have to be a little bit patient with them because they can have some manufacturer residue, some old flux on them, and it can be a little hard to get a reading through it. It can troll you very easily. Alright, let's find ourselves a ground and check our big capacitor. And again, we're checking the trace going to Pi 3 USB, and that appears to be fine. Very good. So, it looks like we just have a port issue, but we will not know for sure until we get the port on and we do a test. So, up next is to do the necessary cleaning so that we can get the port on and go from there. Alright, so I want to perform a little bit of a meter walkthrough real quick just to be certain we don't have any like bridges. The port went on fine and everything. It's just, see, for some reason I just want to check today. So make sure we don't have anything unexpected. Alright, everything looks good. Alright. So, let's perform a power test with our USB, with our power supply, which will be right there. channel 1, and see if we're getting any behavior that we expect. Not really there. Yeah, that's not behavior that I'm expecting, but these things can be a little bit flaky with the power supply sometimes. So what we're going to do is we're going to flip this. Well, actually we're going to try the battery dongle and try activating with the OEM. That'll be our next step. Don't ever want to just assume the reading you're getting from one thing is the end all be all. So let's turn on our channel 2. Activate. What we want to see here is a steady decline in amperage. Yeah, it looks like we're getting that. I wouldn't expect it to be hanging on 0.28, but we also don't have a whole lot of things hooked up. All right, one more test. We're going to connect our USB meter. And this thing only activates one way. It's why I don't really recommend it as a testing unit, but I want to show you. So it'll only activate on the OEM charger one way. That's if it wants to behave today. Do you have it on? Yes. Yep. And right now it is not behaving. Okay, there we go. Finally activated. Okay, let's see if we're getting our 15 volts. And we are. Excellent. Okay. So we are definitely getting communication with the M92T36. And that's a good thing. So next thing to do will be to reassemble and see what's going on, because I need to see a boot up and all that to know for sure if we have an additional issue or not. So we'll assemble enough to test and go from there. Okay, we're ready to perform a test with my known working battery. Charge the battery. Try with the power supply again. Channel 1. Okay, full battery symbol, that's a good sign. Booting up, now fast charging. Attach Joy-Con control to Joy-Con, cannot be used wirelessly, blah blah blah. Alright, anyway, we know we're powering up. I'm going to test the other side. Alright, and we're charging on both sides, so that's a good sign. I'm going to power it down. I'm going to reassemble. It's giving me a Joy-Con error, so because it's in airplane mode, which is fine. I don't really care about that. But fan was moving. Everything's good as far as we can tell. So we're going to reassemble entirely, let it charge on its own battery, and then test from there. We need to test, make sure that it, well, dock-wise, we need, port-wise, we need to check and make sure it's docking. And I like to do, your standard Wi-Fi tests. Well, it's in airplane mode, so I don't know why they have it in airplane mode. So I may not be able to perform the Wi-Fi test, but we'll be able to perform the docking test. We'll be able to test the cartridge reader and stuff like that, just to make sure everything is copacetic before it leaves the shop. Anyway, we'll be back when we're ready to do that testing. Okay, we're back. We've been charging on its own battery using the OEM charger for a while. And as you can see, everything is charging up fine. Now, I'm pretty sure I cannot do an internet test because for some reason they have airplane mode on. I guess I could turn it off for a moment and do our internet test. Make sure we're picking up our networks. Now I'll turn our airplane mode back. Yep, I see them all. Good. Okay, we got my game. Once I figured out how to get airplane mode back on, it's a little bit, I don't think Nintendo really wants you to use it with airplane mode on. Alright, let's load our game. Make sure it's reading. It did. It picked up the game. That's the first game there. Very good. That's all I really need to see on that. Alright, so next thing I need to do is I need to set up for dock test. And that's really the last test we need to perform. So we'll be back. Okay, we appear to have some sort of issue going on because it is most definitely not docking. I checked everything in between and I'm not getting any indication as to why I shouldn't be docking here, so we have an additional problem of some sort. It is dock syncing with the dock. I don't know if you can see that on screen, but it is green lighting, so it's detecting it, but it's not displaying a picture. I'm going to go run through the settings on this and see if they've disabled something else, and we'll go from there. Okay, let's touch around the Pi 3 USB again, because there's really not anything else on this particular version of board that would typically cause this problem other than the port or the Pi, and I'm pretty confident in our port job. So I think we're having a Pi 3 USB issue that is probably some sort of graceful fail. It does happen with them. But I just want to check. Need a good ground connection, but actually I don't need the ground connection, I just need to make test these filters one more time. Make sure we didn't miss something. Pretty sure we were thorough. Yeah, we're not shorting. Alright, so it appears to be a partially working Pi 3 and the fact that, you know, it's not stopping the thing from working, but it is definitely not docking either. So, however, we do have a little complication in the fact that we just replaced the port and we use 6337 solder, which is much lower temperature than the solder holding on that their chip. So we want to protect that port as much as we can and keep the heat off of it as much as we can while we're replacing that chip so it doesn't fall off or something of that nature. Okay, we had a little bit of struggle with getting it aligned. I was pressing down a little too hard apparently. And it jumped on me. That's all right. We got it sorted. The heat shield protected the port, so all good. Hopefully it will be docking again. Otherwise, we have something going on with the port. At least that's a pretty good bet, assuming we have a good part. Anybody seen recent videos know that getting good parts can be a bit of a gamble. So I'm going to clean the rest of this up off screen, and then we'll put it back together enough. We'll put it back together enough to do a dock test and go from there. Okay, and as you can see, it's finally docking. It took me 3 times putting it into the dock. I don't know what the heck's going on with that, but I may need to clean the dock port. That could have been the original problem too, but I don't think so, because I tried many times to get it to dock in the first time around, and this one only took like 3 tries. So anyway, it's working, it's docking, it's charging on both sides, everything else is working, so that should be good to go. Okay, in summary, we had a Nintendo Switch with a bad port. It was just structurally bad. It was not your normal bent up pins or wrecked stuff, but the plastic piece in the middle was structurally weakened. It was moving around, it was coming separated from the pins, and they had tested it at the shop and were not able to get the power up. That's what they thought is either the port or the PMIC. So we couldn't really do anything until we changed the port. We changed the port, everything looked good, we reassembled, and we got the kind of the worst fault. The worst fault you could get at the end of a repair, and that is the no docking. Because you typically reassembled the whole switch by the time you perform a docking test, because it's really kind of the last test to perform, and you got to disassemble the whole thing again and change track down what's causing the problem. In this case, it was this revision of board. It really could have only been 2 things. It could have been the port that we put on, but I felt real good about the port placement, so I didn't think it was a port, or the Pi 3 USB failing in a way that is not catastrophic. Usually if the Pi fails catastrophically, it will stop the switch from even being able to boot. But if it fails in a more graceful way, it can just cause partial docking or some other fault. So in this case, it was causing not partial docking, no docking. In this case, it was causing no docking, so we opted to just replace the chip, even though there was no measurements or anything indicating the chip was bad, but it was a chip. Anyway, we changed the chip, reassembled it again enough to dock this time instead of reassemble it entirely, and it's docking now, so everything should be good to go. That's really it for this repair. If you have any questions about the equipment I used in this video, take a look in the description below. They're all Amazon linked down below. If you click on any of those links and buy anything on Amazon, a portion of that will help go to helping the channel, and will be greatly appreciated. We also have some other support links down in the description if you want to take advantage of those instead. If you like the video, do me a favor, hit the like button. And if you want to see more videos like it, hit the subscribe button and the notification bell, and you'll know when I post videos, usually about twice a week at this point. If you have any questions, please post them in the comments below. I'll be happy to answer them. I love seeing questions in the comments. It means people are engaging with the content. So I'll do my best to answer them or direct you somewhere that I think can answer them. I don't have every answer, so. And boy, that's really all I had to ask of you. I appreciate you watching, and we'll see you next time.